biologist from Massey University in Auckland.
I have a small research group at Massey University, and what we're interested in doing is studying why bacteria have evolved to be the way that they are. I think today we're going to talk a little bit about bacteriophages and how we're planning on using them to help honeybees here in New Zealand. So bacteria live in every part of the world around us, and most of them are completely harmless or doing really great things for us. And that's important because that's not true of all of them. And the ability to selectively target the ones that are bad and not the ones that are doing great things is an important thing. And so one of the reasons that we've got interested in the viruses that are able to kill bacteria is because they're highly specific. So viruses come in a lot of different shapes. So this is a virus of bacteria, or what's called a bacteriophage, or just phage for short. And for every bacterial cell that we might want to kill, there are estimated to be about 10 bacteriophages that are specifically probably like targeting just that particular bacterial cell. So they're highly specific. If you send in an army of bacteriophages that are able to kill a particular bacterial cell, they'll only kill that bacterial cell. So phages are awesome. So a new project that we have in our laboratory is the ABATE project. And this is active bacteriophages for AFB eradication. So what is AFB? AFB is a disease that affects honeybees in the hive. And this is a disease that we have been trying to eradicate in New Zealand for the last 30 years. And one of the things that happens is that if a beekeeper recognizes that their hive has been infected with AFB, then as soon as they recognize this disease, they have to burn the hive. It's been shown in the United States by some work that there are bacteriophages in the soil that are able to kill the organism that causes AFB, which I'll say is Bacillus larvae is the bacterium. And we're gathering soil samples from all over New Zealand so that we can find the bacteriophages that are already in our soil that are able to kill this particular bacterium. And the way that we do that is we have people send us soil samples, and what my PhD student will do is take that and grow it with the Bacillus larvae to see if we can find any bacteriophages that will grow. And if anybody in New Zealand sends us a soil sample or bee debris that has a bacteriophage in it, they get to name the bacteriophage. So my undergraduate students at Massey have done projects like this with different organisms, and they've come up with names like Fancy Pants. And once we've found a handful of these, we're going to put those together in a cocktail and see if they can actually protect beehives so that they are not infected by Bacillus larvae and so that they don't acquire this AFB disease. And so that's the project that we're doing. And people can write to us in the contact there, and we're happy to send out envelopes so that anybody can participate in this project. Much of molecular biology and the kinds of amazing things that we're able to do today really sprang from studying bacteriophages in the first place. So they're a simple entity that provides us with this amazing window on the molecular world around us.